All right, thank you for joining us today. We're going to give it a couple of minutes um, as people come in. We'll get started in 1 or 2 minutes. So please get settled in and we will kick off shortly. Still people coming in, so let's give it a minute and we will get started. Give it one more minute and then get going. 30 seconds as people are coming in and we will get going. All right. Thank you, everybody, for joining us today for high performance, ultra low latency with Red5 and Zixi. My name is John Westcoat. I run the partnership and marketing groups at Zixi, and I am joined today by Tim Baldwin, VP of Product for Zixi, as well as Red5 CEO Chris Allen. Today's agenda will be to give a brief Zixi overview, get to an introduction to Red5, how Zixi has been integrated, and then give a live demonstration. We will take questions at the end. So as you have questions going through the presentation and the demo, please put them in the Q&A tab, and we will take and answer as many as we can. If we're unable to get to all of your questions, we've got your name and email address logged, and the appropriate subject matter expert from Zixi and or Red5 will follow up with you. One common question is, will this be recorded and distributed? It will be. So we will send that out in the next day or so once our presentation is done. And with that, I will turn it over to Tim.
Okay, thank you, John. Okay, so Zixi is defining the category of software-defined video platform in broadcast media. Zixi is not just a protocol, as many people might think or know of Zixi from many years ago, but instead it is a robust platform for the aggregation, management, and distribution of both live linear and live event content. And that's over any IP network, it could be wired or wireless, on any cloud provider or any data center or any on-prem location, to any type of endpoint, and using any protocol, including the Zixi protocol that we all know with 15 years of maturity, but also every other relevant protocol in the industry. Next slide. So over the last 15 years, Zixi has built out the largest ecosystem for live video delivery with 400 integrated partners in the Zixi-enabled network. We have support for every relevant IP protocol and have built-in efficiencies in both bandwidth and compute resources that reduces costs by 50% or more versus other solutions. Next slide. Oh, I see. Yeah. Okay, yeah, so we can move to the next slide. The Zixi-enabled network with 400 partners is critical for solution deployment and covers a large range of use cases from delivery into and out of edge devices. into service providers, and into all the different application layer systems that are used in the business of broadcast television and sports. What's important here is that these relationships with these partners and the integrations take many years to achieve. For Zixi, it's been well over a decade that we've been working with partners and growing, the list of partners that we've integrated with. Zixi is a best of breed solution that is trusted by 95% of broadcast vendors, and that's large, medium, and small. Next slide. The Zixi software-defined video platform includes the Zixi Broadcaster as the workhorse at the center of this diagram. The Zixi Broadcaster ingests any protocol, analyzes the video for TR101 and content issues, processes the video with PID mapping, demultiplexing, multiplexing, transcoding, and then delivers the video in any protocol, including transport stream protocols like Zixi RIST SRT, segmented protocols like HLS and Dash, as well as legacy protocols like RTMP. On the contribution side at the left is Zixi Edge Compute standalone contribution software, and also the Zixi Feeder SDK library that's embedded in encoders from Elemental, Atem, Harmonic, Videon, and most others. And this provides a robust Zixi protocol contribution to the Zixi Broadcaster. On the egress and receive side, on the right, we also have the Zixi Edge Compute standalone receiver software and also the Zixi Receiver SDK library that's embedded in IRDs from all the major vendors, as well as set-top boxes and other devices. And this enables delivery of robust Zixi protocol to the edge. Finally, on top is ZenMaster, which is the orchestration and monitoring software that manages thousands of broadcaster instances and tens of thousands of channels to enable very large-scale deployments for our customers. Next slide. ZenMaster really it's the operational hub of large-scale Zixi deployments, and it provides the control and the visibility and the automation and the monitoring that's required for high-value live linear and live event workflows. And with that brief introduction to Zixi, I think we're now ready to jump over to Chris from Red5.
Hey, thanks for that, Tim. And yeah, thank you guys for having me on this webinar. It's an honor to be working with Zixi. We've had nothing but great experiences with you guys, and I'm really excited about what our two platforms together can do. So yeah, we're a real-time live video streaming platform. We're primarily focused on being able to scale real-time video, and it's a full stack solution built around our open source core. And we do have the ability to deploy on. It's like a cross cloud solution. You can deploy on any cloud provider. And we offer client SDKs, to write native applications and browser applications. And we're primarily known for WebRTC based streaming, although we do support, just like you guys, quite a few other protocols as well. Most of our leads come in from partners, and so we're a very partner-centric company overall. And our main verticals that we focus on are live sports, media and entertainment, as well as this other kind of category, which we call surveillance, but often involves like traffic monitoring, drone streaming, and kind of government type applications like that. And our business model is really a licensing based model where it's a per node usage model with a subscription on it. So this is that unto itself is a bit different than most of our competitors in this space. Next slide. Yeah, so a lot of the use cases that we focus on are in this kind of new interactive media applications, interactive live streaming apps, which cross a bunch of different verticals, whether it's online shopping, virtual casinos, auctions have been a use case that's been around for a very long time. It's really wherever the video stream latency needs to be as low as possible to be able to basically allow for live interaction with it. And Yeah, and that crosses multiple industries, but again, you know, some of our biggest are in sports and also in this kind of government and aerospace and defense kind of categories. Next slide. You know, these are some of our customers that we work with. You know, Proxybid is a very large auction company that they rely on our software for providing live streaming and keeping it in sync with the events. We're doing a bunch of interesting things with Verizon. They've used us for drone streaming in the past and quite a few other use cases. Yeah, next slide. And, you know, again, we are pretty unique in the sense that we can be deployed on your own cloud account, and we support any cloud provider that Terraform supports, which is a whole slew of them. And we do have partners with all of the major and some of the more minor cloud providers. Next slide. So as one example of some of the work we've been doing with Teledyne FLIR, we actually power the live streams from traffic cameras in the Los Angeles district for Caltrans, and this is over, I think, over 1,000 different cameras coming in, and they've got this pretty amazing like video wall center where they can actually monitor any of this stuff. Before they started using our software, the latency that they had on it was, you know, typical HLS, 30 seconds and everything else. And when they had a situation or some kind of emergency like wildfire or traffic accident or anything else, these cameras were kind of a little bit difficult to work with to figure out what was going on in real time while communicating with law enforcement or other groups like that. And so we've really shaved off the time, so it's truly real time what they're seeing. And we've even developed an application, like a mobile application, so that they can also get different views that wouldn't be possible from the straight IP cameras that are on the highways. Next slide. We also work with a company called a Zero Group. They do the streaming for NFL studios, and they've got a pretty interesting application using our platform that does PTZ cameras. It allows them to have full control of those and run a studio remotely, which is a pretty exciting use case. Next. And there's another young startup called Dale in Brazil, who's allowing for live commentary over the top of soccer games. And as if any of you guys know Brazil, they're kind of obsessed with soccer. And these kind of popular influencers are extremely well liked, and they get a lot of followers. And so what they're doing is kind of marrying the game experience with allowing people to listen to the color commentary from different groups. And so you can basically pick different ones from the list and get that feed. And this is working so well, and that a lot of these influencers will actually broadcast straight from the game, and the thing is perfectly synced. And some people are also listening to the Dale app while at the actual soccer matches, and it's staying completely synced with the experience. We've been doing a lot of kind of POCs with some major sports groups as well, doing things in stadium where the latency has to be precisely synced with the game that's actually happening. One event we had this summer, you could actually, the speed of sound was actually in sync with the video, like this multi-view application that you can see on your phone. And that was a pretty compelling experience. So lots of really cool stuff in sports that's starting to emerge, and I'm very excited about that. All right, next slide. So what about Zixi and Red5 together? Well, a lot of the use cases are kind of around this end-to-end solution with keeping the latency as low as possible. Certainly less than 500 milliseconds. Generally speaking, though, you're talking in the 200 to 300 millisecond range in most use cases. And then also the ability to deploy multi-cloud or even on-prem, as a lot of these groups are still using on-prem capabilities. And then scaling to any size audience. We support cloud recording. We've got the ability to mix the streams, server side, a bunch of other really interesting ways of leveraging our platform in that sense. And ability to send out to third-party services like Facebook Live or YouTube or Twitch. You can use our platform to do this sort of things. And then we also support transcoding for ABR. We have our kind of unique way of doing ABR over WebRTC. And so it can shift up and down depending on the quality and what you need. And synchronized video playback. Yeah, this is one of the really cool things that we're doing. We've got these multi-screen and watch party capabilities, which we've released with this True Time Solutions, which are available as open source projects, which you can start from. And then we also support DVR scrubbing and playback. So it's not just the live real-time stuff, but also the ability to take this and run kind of time shifted stuff. So you may be watching a game live and as close to real time as possible, but then you need to pause, you want to scrub back and see the play again, and then you want to pop back to real time. We can do all of that. And we leverage basically HLS for the time shifted stuff, and then back to WebRTC for real time. And then probably one of the more interesting things is the ability to sync data in a very frame accurate way across multiple streams, an ability to do multi-view and let's say like an auto race, and then also getting the telemetry data from the cars and understanding what is happening in real time. Maybe it's the tachometer of each vehicle. And, you know, as you switch views, you can get the metadata synced perfectly with what's happening in real time. And then, you know, again, like the ability to do this on-prem means that, you know, the video latency has to be precisely synced. All right, next slide. So we're going to show a quick demo. Basically, what we're trying to show is Zixi feeds coming in and then splitting them out. So like a traditional HLS pipeline, and then another one where we're using our platform as the distribution. And so you should be able to see the relative latency of these things. And I will try to, I don't know, Tim, do you want to explain a little bit about the Media Connect aspect
Sure.
of it?
Yeah, let me jump into this. So
Yeah.
we have a lot of customers that use Zixi broadcasters deployed in the cloud, and we also, there are a lot of companies out there using Media Connect, which has Zixi technology built into it. So for this demo, what we thought would be interesting is just, you know, show a comparison between a typical HLS distribution workflow versus a Red5 distribution workflow. So what we have here is a Zixi-enabled encoder pushing Zixi protocol up to Media Connect. And then from Media Connect, we have, you know, one leg of the pipeline here goes over to Media Live for transcoding, media packets for packaging, and CloudFront for delivery. And then the other leg via Zixi protocol goes to Red5 and uses the Red5 WebRTC XDN for delivery. So we thought it'd be an interesting example of a, you know, a kind of a typical HLS workflow versus a Red5 WebRTC based workflow.
Right. And then, so the box there, the Red5 XDN, we kind of have this term, XDN is Experience Delivery Network. This can be deployed on any cloud. I think the one we're going to run on right now is on DigitalOcean. And if you kind of go to the next slide, John, and kind of show what that looks like. It's the stream managers are kind of the brains of the operations. They're connected to a local data store on the cloud provider. And then they use Terraform to then basically spin up origin nodes, and edge nodes is what we call them. And the origin nodes receive the incoming stream, and the edge nodes take care of distributing it out to WebRTC clients. And so, and then the stream managers are generally load balanced in front of some kind of like an elastic load balancer if this is deployed on AWS. And so let's see if we can jump into the screen share. I don't know if you can give me permission to do that.
Yep, let's get that going. And while the demo is coming up, I'll remind everybody, if you've got any questions, please put them in the Q&A tab. And after the demo, we will answer any questions that anybody's got.
All right, very cool. It's giving me the ability to do it. So let's see. All right, are you guys able to see my screen now?
Yes.
Yes.
All right, fantastic. I love it when things actually work. So this on the left is the Zixi to HLS using the standard pipeline that Tim outlined. And then this side is using Zixi through the Red5 XDN cluster. And then I've also got a feed here in WebRTC. And actually, if I go back and start my camera in the, what do you call it? In the Zoom webinar, hopefully you see that being pretty much in sync with what you guys are seeing out there in the webinar. So we just kind of wanted to show that as kind of a relative thing. It's really hard to show off latency on these things. You can see here, we've got an offset of about 20 seconds. That was kind of fun because it just rolled over right as I said that. So it made it really easy to calculate. But this is fluctuated up and down, which is interesting because the HLS tends to kind of shift quite a bit, and every participant will end up having a different kind of experience. So synchronizing this stuff, especially when you have applications where people are trying to do things together, like webinars or other things where it's really time sensitive, it makes it almost impossible to do. And then this stream is coming in almost in real time through the Zixi. So basically, Tim, right, you basically sent us a stream over to Zixi protocol and then skipped the media live aspect of this, right? And then that's how we're getting that feed.
Right. Yeah. You're pulling the Zixi stream directly from Media Connect. And then Media Live is pulling behind the scenes an RTP stream from Media Connect.
Right on.
Yep.
So and then this again is just kind of me grabbing from the camera and sending over WebRTC so that you could see this kind of reflected back at you. So,
and I guess I think what's what we want to one thing to talk about is the scale, and you kind of alluded to it in the last slide we're looking at, but the XDN that you guys can create will scale out over multiple origin and edge servers as necessary to support large both large and small audiences.
that's right. Yeah, it's it has the ability to continue to spin up instances on the cloud network or a private data center for that matter to actually scale to whatever size you need. And it does that as an audience is coming on, and it auto scales and adjusts to that stuff as needed. You can also provision nodes into the future, and like we have an event scheduling API that allows you to kind of set the capacity that you want. So if you were going to have like a big event, like a motorsports race or something like that, and you know exactly the time that people are going to be watching it, you could scale it up accordingly.
Right. So you have the scale, but you also know that everybody's seeing the event at the same time. Every viewer is seeing the same thing at the same time.
That's right. And then, the interesting thing is we've also been seeing a lot of production use cases where teams are trying to collaborate and see like confidence monitors of what's happening in real time. And our platform's proving to be extremely useful for that, especially with kind of multi-view type stuff going on.
Right. Yeah, and I think with the multi-viewer especially for a live event situation, the multi-viewer having all the streams be in perfect sync with with the wall clock also is quite necessary.
Yeah, absolutely. Yeah, particularly when you start getting into the, in stadium type use cases. But then there's sports betting too. You want to have everything you don't want people to be able to cheat by being at the event. And then these micro betting use cases are really driving the latency to be as low as possible. Yeah, in fact, we have one customer in Ireland who's doing kind of all the betting shops through UK and Ireland, and we're streaming that content over WebRTC so that then there's no way you can be at the race and actually know what's actually happening and feed somebody that. So yeah, we're seeing all kinds of really interesting use cases like that. It does look like we have one question. Should I go ahead and try to take this one?
Yeah, let me read it for everybody.
Okay.
And we've got multiple questions here. The first one is, how does Red5's true time solution adapt and maintain synchronization in real-time environments when faced with up to 30% random packet loss? Can you elaborate on the key mechanisms or algorithms employed to ensure accurate and consistent timekeeping in such challenging network conditions?
Yeah, this sounds like a pretty extreme situation where you have 30% packet loss. But yeah, we have the nice thing about WebRTC is it's really built for real time, and it does have packet retransmission capabilities, which is what we're basically tapping into. So we do use NAC and various other things to adjust on the fly, and then again the ability to shift the bit rate and the quality of the video down for users who want to stay in time, but just aren't able to keep up with the bandwidth. It'll automatically shift to those. So, I mean, that's the short version of it. There's all kinds of other like levels of details inside of this to make it pretty complicated, but hopefully we're making it simple for the end user and the people using our platform.
Next one, does this real-time technology support ad insertions to monetize content for each user like SSAI?
Yeah, so we have a kind of this interstitial technology, which allows you to insert anything into the stream, which could easily be advertisements, or even just like, hey, we're on hold right now, that kind of situation. One of the cool things about the Red5 platform is that you can actually write your own server-side applications, which then you could tap into your own ad platform and then pull those streams in and then distribute it out to the clients in real time.
Awesome. Tim, we've got a question about ZenMaster. The ZenMaster slide was impressive with a lot of deep monitoring capabilities. How is that being used in live sports?
Well, let's see. Without naming names,
we're all friends here.
Yeah, we're all friends here. Yeah, the one of the key things that ZenMaster offers is live event scheduling. So, you have your normal linear 24/7 content, and then you have live events, and around the world on any given day there's probably tens of thousands of live events. And what you can do with ZenMaster is have it on a schedule, spin up the workflow at the right time. So in the ZenMaster terminology, we have channels, and channels are fed by sources, and then then a channel is distributed to multiple targets. So those assets inside ZenMaster will get configured and spun up dynamically based on the schedule. But also, as we know, live events, and especially sports, the the schedules aren't always fixed. You know, be it a soccer match or football game that goes into overtime. So the live events manager inside ZenMaster, everything's based on a schedule, but it also has a manual mode that an operator can go in, and let's say it's a a football game that's gone into overtime. You can switch into manual mode. So then the transitions that happen in a live event, the kind of the pre-event versus when you're in the event versus the post-event, you can manually decide when that, when a transition happens, if if there's a change happening in the live event. I remember there's one soccer game I was watching where the game actually didn't start on time because of some reason. I don't remember exactly what it was, but the game started like 23 minutes later than it should have, which is a rare thing. But in that case, even if you have everything automated, you want to be able to go in and manually adjust when you transition from a kind of a pregame slate or slate type content over to your actual live feeds. So that's one of the main ways that ZenMaster is used for live sports, is being able to manage live events. But then of course once the feeds are running, there's all the monitoring, the TR 101 analysis and content analysis and things like that the operators are watching as well, to from a monitoring aspect. So I think that's pretty much how we we see
Tim, I
customers.
wonder if it's worth speaking about this kind of new use case that's come up recently with us, and the ability to do live monitoring using the Rev5 for the WebRTC aspects of it, and then using ZenMaster to do exactly all the things that you were talking about.
Yeah, absolutely. So if let's imagine you have your your workflows for live events in starting out in ZenMaster. Then with Red5, you can also pull Zixi feeds for all your different camera angles, for example, and composite that into a multi-view that's just pretty much real time. And then that multi-view can be used kind of in parallel with the ZenMaster monitoring for kind of the visual, a way to visually monitor all the camera feeds that are coming out of that stadium or facility.
Right. And then you use ZenMaster basically to tell you, like, if there's from a technical standpoint on any of the feeds, what does that look like and what's the problem? But what we've been seeing in sports is a lot of these guys want to know exactly what's happening at the time,
Yep.
just for things like switching to commercials, and getting that timed perfectly.
Yep.
I think in the traditional ways of doing this, it's actually quite hard. And there's a lot of guesswork going off, and sometimes cutting off commentators as they're going to commercial break and things like that, which can be avoided in this scenario.
Yep, absolutely.
Next, I guess we'll put this to both Chris and Tim. For private networks, is Zixi Red5 a relative replacement for vBrick or Haivision deployments? Chris, you want to go first? Tim, who wants to jump in on that?
I mean, certainly Haivision tends to be more of a encoder company. We do partner with other encoder companies. We also do support Haivision for that matter, and can take SRT streams into our platform, which I think Zixi can as well. So I think it's more compatible, not necessarily competitive, but a lot of the use cases, I know Haivision is kind of doing this full end-to-end solution with their SRT gateway type stuff. I think a lot of the pieces could be replaced for sure. And then, they don't necessarily have a WebRTC distribution, so you'd need to partner with a group like us to do that aspect of it. I don't know, Tim, if you have
Yeah, I
more.
think there definitely is a lot of overlap in the solutions. I guess the one piece Zixi doesn't have is we're not an encoder company, but we partner with all of them. And all, pretty much all the encoders out there have the Zixi SDKs built in. So yeah, I think the short answer is yes. Between the Zixi and Red5 solution, you could replace high vision, or VBrick or other, kind of on-prem solutions. And really it would just be trying to figure out what problem, is there something lacking in the current solution? Is there a problem to be solved that we could solve better with, with our respective technologies?
Yeah, I mean, certainly with the latency thing, the best performances we've been seeing are with Videon and Osprey.
Yep.
Osprey in particular has a WIP support, so we can send direct WebRTC streams into our platform. So that kind of becomes an interesting. Videon's really been tackling this concept of sending synced metadata with the live stream. And so each of the platforms have their advantages, of course, and also cost models.
Yep.
But
What-
yeah, go ahead.
Yeah. So I guess one other thing I'll mention is, your private networks. Let's say it's a large organization with fiber backbones around the world. People who don't use fiber networks, I think, assume fiber networks are flawless. I think people who actually do end up using fiber networks, even managed ones like MPLS, there often are, packet loss events and, and other events that happen. So with Zixi and the Zixi protocol and the protection that it provides and the monitoring in ZenMaster, you can you can get better results even on fiber networks when issues happen, and even more important, when you're seeing issues on your fiber network, and you can use that with your IT teams to help pinpoint what's happening. A lot of times fiber networks, as they're just turned on, but there's not any inherent monitoring on the networks, and so when issues are occurring, it's the customers have difficulties trying to track down where those issues are happening.
Thanks, guys. Next, we've got a couple of questions about WebRTC latency. I missed what a latecomer possibly missed what the WebRTC latency is, and can they see a source in the window to look at the overall latency?
Yeah, so this video here is the delayed one, and then this is, or HLS feed, this is the WebRTC. So you can see an offset of about 24 seconds, 25 seconds, somewhere around there. And then I can turn on my camera again on the webinar, so hopefully you can see the relative latency of the webinars through Zoom, and then the straight WebRTC coming through the Red5 platform. So hopefully, it's definitely difficult to demo latency this way.
Trying to see the source, that source exists on Media Connect. I think what we set up here was a 300 millisecond connection on the Zixi stream from Media Connect to the Red5 server. If we were to try to show the source, so to speak, you could maybe pull up a VLC window that pulls that same Zixi stream, but then it would just depend on what latency we set up in that Zixi protocol stream that goes to the VLC window. So I think it, like Chris said, it is hard to show the latency, but basically the latency you're seeing in the camera feed versus Zoom, I think that's probably the easiest way to demonstrate the WebRTC the WebRTC part of the latency.
Yeah, the tricky thing here is that this is, of course, we wanted to share this out, but I'm actually stealing our release server, so I didn't want to share that out with everybody. But yeah, you could actually take a look at the stream yourself. And yeah, so the screen share probably is making that a little bit difficult. But one other thing is, like, just in our testing, Tim, it may be worth kind of talking about that. When we shave down that the Zixi buffer, you know what I mean? We've gotten it down to something ridiculous, like 10 milliseconds, where then of course it's not able to do the packet retransmission as efficiently. But on
Right.
a local network, that's kind of what you want. You're not worried about that. And then we've seen end-to-end latencies of about 60 milliseconds round trip time
Yep. Yeah.
on local networks.
The so maybe it's a good chance to talk about the Zixi protocol itself a bit. Um, so the Zixi protocol uses both ARQ for retransmission and FEC, and it dynamically allocates how much ARQ or FEC it's using based on the latency target that you set and the round trip time of the network connection. So, let's say you have a round trip time of 50 milliseconds and you set your latency target to 500 milliseconds. In that case, there's plenty of time to do retry requests. However, maybe again, your round trip time is 50 milliseconds and you set your latency target to, let's say 50 milliseconds. In that case, what happens is the algorithm will dynamically shift into FEC mode and not even try to do ARQs. And then so then you can achieve the super low latency. So the nice thing is the user doesn't have to worry about this. Basically, you just need to decide what do you want the latency to be from point A to point B on the protocol, and then the algorithm itself, based on network congestion and round trip times, will pick the best mix of ARQ and FEC to achieve your latency with the most reliable stream.
Yeah, and WebRTC has its own mechanisms for doing that sort of stuff too. It mostly uses NAC for the packet retransmission. And then on our server side, we keep up to a second of back packets to be able to resend critical packets as needed. But generally, it's keeping up as close to real time as possible.
Yep.
Right.
And I guess both, another point is both protocols, Zixi and WebRTC, are based on UDP. So, the time it takes a packet to get from point A to B is just the time it takes to transit over the network. I mean, that is kind of your theoretical low side of what your latency will be.
Got a couple more questions. Chris, does Red5 have open source options?
Yeah, I mean, our core is open source. So we've got a full media server which is available. It's under the Apache 2 license. That actually is what's driving our entire platform. So a lot of that is available for free and open source, and people can take it and manipulate it. Also, the entire application structure for building apps on top of Red5 is open source. And then we've got these new true time solutions where we've got fully baked applications that people can take and run themselves. We've got a multi-view, we've got a watch party, a lot of other really cool things that you can take and use yourself. So yeah, open source has always been a big part of our platform and our kind of philosophy too.
Back to Tim. What about adaptive bit rates? How does that get managed within this setup, especially regarding switching and potential impact on latency and catching up?
Oh, actually, I think that'll be a Chris question because the adaptive bit rates are done inside the Red5 platform.
Yeah. So we actually have a couple of choices. You could either configure an external transcode of that and send multiple variants to the Red5 ingest. And basically you provision that with those different levels, or you can have us do the transcode on the fly. We have a real-time transcoder which can be deployed in the cloud, and it will take care of setting those the bitrate ladder. And then the way it works on the client is essentially you've got basically the web part of the WebRTC spec is this idea of a control channel. So it's the RTCP channel. It sends different messages over that. One of which is trying to remember the exact name of it right now over the top of my head. But there's actually a couple of different protocols that we use for basically knowing what the available bandwidth of that client is, and then we can adjust up and down. The trick there, of course, is on each of those edge nodes, knowing when to shift and not doing it too aggressively, because you could have a lot of fluctuation going up and down. And so we've got a pretty sophisticated system which shifts once it's detected enough of those messages saying that it's too low to keep up. And then it just basically, the edge node in this architecture basically shifts which stream it's sending over that UDP channel. And then you've just adjusted down to help that client keep up.
Is that, I'm just curious, I think with HLS, it's a player side decision to
Yep.
shift, but in this case, it sounds like it's the edge server making the decision to shift.
That's
accurate?
correct. And it's
Okay.
based on, it's the REMB message is what is a receiver estimated bandwidth, I think is what that
Okay.
stands for. And yeah, we basically, the edge node keeps track of each of the clients connected to it. It's actually not even technically a client, because WebRTC is a peer-to-peer protocol. So each of the peers connected into it, it's maintaining a state and knows like whether it needs to shift down or up. So yeah, it is completely the opposite of the way you do it with an HLS feed, where HLS, the client is actually going and grabbing a different set of video files to pull down, right?
Yep.
In this case, the edge server node is actually sending different data based on the client and what it can keep up with.
All right, last question. I like this one. It gets to the fundamental question about scalability, which is one of the tenets of this partnership. How do things change when attempting to scale to hundreds of thousands of streams like a Twitch style service?
Yeah, so I don't know if it necessarily changes, because our platform has the ability to add as many edge nodes as you need to scale it. And we can also deploy in multiple regions. So I guess you're talking about like probably a very popular Twitch stream where you've got hundreds of thousands of people watching that thing. And so in that case, it's just a matter of having enough cloud, in the case of AWS, EC2 instances to throw at it. Each node can handle, a few hundred streams going out of these edge nodes. Of course, that depends on the stream quality, the frame rate, and a bunch of other factors. And then also what type of instance you're using. But in general, all of those things are set to scale whenever it detects a load, and then it can actually adjust on the fly. So really, it's a matter of throwing enough server instances at it to handle the load. We regularly do, 100,000 as part of our QA tests, concurrent WebRTC streams going out. And then, we've seen other use cases, I can't talk about them publicly, where it's going much higher than that. But yeah, the thing kind of scales indefinitely as long as you have enough resources to throw at it.
And if you knew it was going to be a big event, you also have the option to pre-deploy a certain amount of resources and then scale up from there if necessary.
That's exactly right. Yeah, you typically don't want to rely only on the auto scaling, because it does take some time for those cloud instances to come online, usually about a minute or so. It will do that in parallel, right? So it'll spin up a bunch of them all at once. It's not like it's going linearly, like one by one by one, which would take forever for it to adjust. But yeah, generally speaking, if you know you're going to have a big event, people tend to provision enough nodes to kind of handle the upfront possible traffic.
All right,
But I
Chris.
think it looked like Steve had a clarification there. It's more about carrying 10K simultaneous streams.
Oh yeah, so instead of it being one stream to a large audience, maybe you have 10,000 streams to small audiences.
Yeah. So we have a lot of use cases like that. That tends to be more the kind of surveillance type use cases where you've got thousands of cameras monitoring either rocket launch or like a military operation or something like that. Yeah, so we do the same thing. We just scale the origin side. So the number of streams coming in, you just set the number of origins you need to handle all of that traffic coming in. So it's kind of the just the reverse, not the reverse, I guess the other side of it, we can scale as well. So the origin
Scale on the contribution side, or you can scale on the delivery side, or both.
Yep, exactly.
All right, guys, thank you very much. Tim, appreciate it. Chris, thank you for joining us today, presenting and doing the demo. We will make this recording available to all of our attendees, as well as those that registered and were unable to make it today. And then we're happy to follow up with any questions that the group has going forward. So thank you for joining us today. Thanks, Chris. Thanks, Tim. We'll talk to you guys
Thanks,
soon.
guys. Really
Okay,
appreciate it.
thanks, everyone.
Take care.